Hi everyone, and welcome to today's webinar organized by JetBrains. I'm Jodie Birchall, data science developer advocate, and I'll be your host. The topic for today's webinar is I Can't Believe It's Not Real Data, an introduction to synthetic data, and it's being presented by Mason Egger, the lead developer advocate at Gretel.ai, which is a company that generates synthetic data as a product. So welcome, Mason.
Awesome. Thank you for having me.
Yeah, I'm super excited about this topic. And as a data scientist, I know really well the pain of trying to get hold of enough appropriate data. And it can be a real struggle, real time consuming part of the process. So in your experience, would you say this is a common problem for a lot of people, data scientists and developers?
Oh, yes. Yes, as we'll see in my presentation, this is probably one of the largest pain points for developers, especially when it comes to data scientists, the data gathering phase is the largest and most time-consuming phase of the entire process. You would think it would be the model or the training, but no, it's the gathering of the data. Which reminds me of most of the time with developer, or when you're being a software developer, all the fun stuff usually is the stuff that takes the least amount of time, and all the stuff you really don't want to do that seems to just drag on for eternity. So yes. Access to data, all of that is a very onerous process for people, and we're going to cover that in depth today.
Excellent. And I think it's really cool that your company specializes in this in entirety. So would you mind just giving us the elevator pitch for what Gretel AI is doing?
Yes. So Gretel AI is a company focused around building accurate, privacy-protected synthetic data. So we have various mechanisms around generating synthetic data, multiple models, depending on the type of data that you want to generate. We have our original model. We've just recently released a GPT model, which helps more with text-based stuff. We have a couple of other models that are being released. One is an open source implementation of a model called Doppelganger, which is a generating adversarial network. I can never get that right. GAN. And that's supposed to be really good for time series data. And then we're moving on into all of it. So the eventual goal is to build a suite of models for generating different types of synthetic data. And we just released a blog, I think yesterday, about not only using a model to generate synthetic data, but using multi-models to generate synthetic data, which I just read the blog, so it hasn't quite stewed in my brain yet. So I'm still processing it. But yes, doing a lot of really cool stuff on the generation of synthetic data and unlocking data for the consumer, people who need data. Let's get them data and accelerate their process.
Yeah, and it's really cutting edge stuff. I played a little bit with the OpenAI endpoint for GPT-3, and it is incredible. The text that it can generate is so realistic.
Yes. Oh, GPT-3 is. I'm still in the phase where it feels like magic. There's I don't remember whose famous quote it was, that any discernible tech is equivalent to magic, and I'm still in the phase where it doesn't feel like this should be possible, but it 100% is, and it works, and that just seems amazing. Not only are we doing GPT stuff, but if you go to Gretel's blog, you can read some of the other cool things that we're doing. I think the coolest one that we have is we have a case study with Illumina where we're synthesizing genomic data, which I feel
sweet.
that is I think the pinnacle, the peak. I think I think one of our CPO says internally, if we can solve generating genomic data, everything else will be easy, because genomic data has to be some of the hardest stuff to do on the planet.
Yes, yeah, because you're so constrained, but it still has to be meaningful. So cool. So I imagine everyone's pretty keen to get into the actual content. So we have a little bit of administration to get out of the way. We would really like to keep this webinar as conversation and as interactive as possible. So if you do have any questions or issues during the webinar, please do let us know using this chat in YouTube. So Mason and I will both be keeping an eye on the chat, and we'll have a few pauses where he'll be able to answer your questions. And there'll also be quite a lot of time at the end when he's preparing demos. So there'll be a lot of space then. So really, when you have the questions, ask them. Don't just wait until the end. And please also be aware this webinar is being recorded, and the recording will be available right after the webinar ends on YouTube. So with all of that out of the way, I'm going to be quiet and hand over to you, Mason.
Awesome. Well, thank you very much. And it's a pleasure to be here. So today's talk is kind of a pun. I'm a big fan of puns. If you're from America, you know we have fake butter, and one of the brands is I can't believe it's not real. I can't believe it's not but real butter. So I'm going with I can't believe it's not real data, an introduction to synthetic data. Just so you're aware, this is the quality of the jokes. So this is how this presentation is going to go. So let's go ahead and start. So I like to start by like framing problems that people can probably relate to. So imagine that you're, say, a developer working on a web application. I'm personally a big fan of the Django framework in Python. So say you're working on a Django framework application that manages students in a classroom. Let's just talk about classroom management tooling. You're developing, you're getting through to it. Oh, and now it's time to test it. Okay, awesome. Let's test this. Let's see if it actually works. And you can't access the production database for security reasons. For those of you that aren't aware of the American education system, there's a law that is called FERPA, and it basically is student data, and this data is privacy protected by law. We can't just hand out student information to anybody that asks for it. So now we don't have access to it. They don't even give it to developers. It's very heavily protected. So now you have to basically have a test database with only a handful of records. Maybe the developer inputs the records themselves. Maybe they find some way. They use something like to generate some fake test data. But as someone who was a developer who's done this before, and I see all of you in the audience, I know that you're not spending a lot of time creating test data here. I know that you have 3 fixtures that you loaded in, and you're like, it works, and that's all you do. And it's sad, but it works. And because of this, you have an edge case that can slip through because it wasn't represented in the test database. There are many, 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 many edge cases. The likelihood of you catching them all in your testing is relatively low. So that's just one of the problems. Or let's also look at this from a data scientist perspective. So you're a data scientist and you're trying to build some sort of model to do something. Let's, for the sake of, for our example, let's say you're trying to build something that predicts a rare disease. You have all of this patient data and you're trying to predict, like, does this patient show symptoms or something of this disease, or what is the likelihood that they will catch this disease? So you start looking for relevant data sets, but you find out you just don't have enough of the data that you need. You can't find it, and it just, there's just not enough data. So you have to train the model with this limited data set. You know that you don't have enough data, but like you're working with what you have. And the model is relatively unsuccessful, or it's just not representative because the size of the data was not accurate. And then, but wait, someone from another hospital comes to you and they say, hey, we have similar data and we can probably share this with you. And you get super excited and immediately the door slams in your face because you can't access this data because it has personally identifiable information in the data set. And now nobody can. So like you got all excited, your hopes got up, and then immediately out because the laws protecting data privacy don't allow for you to share this data across different hospitals or different institutions. And these forms of what I just mentioned are a few examples of stuff that happens across the industry between developers and data scientists, between testers and DevOps engineers. Every single day this happens. Data and access to relevant data is the most challenging thing that most developers are facing at this current time. And there's a lot of data challenges that we have with that. So let's talk about some of the common data challenges. Access to just usable testing data. This graph right here, and as we had mentioned earlier, kind of goes in and talks about 35% of all data science time is spent in the data gathering phase. So I know this is a little bit small, but if you look at the one on the left is the largest, and that's in blue, and that's gathering data. The model building goes down, the productionizing, the visualizing, and the finding insights. All of those don't take that much time. Most of the time happens in the data gathering stage. So how can we make it where you can access data quicker? And just even if you're able to access it, like it's inaccessible. It has PII in it. It has customer information in it. It has some sort of stuff in it that just doesn't allow you to be given access. Like if you've ever worked at any sort of like small, medium, large dev shop, you don't just get access to the production database because you asked for it. Like they keep that stuff relatively locked down. You have problems with limited data sets. Lack of quality data can really affect the model training. If you don't have enough data or the data isn't representative, then you really can't train a model. You can try, you can hope, maybe your model gets to 50% accuracy, maybe it gets to 60% accuracy, which I guess if you think about it, it's better than not having it before, but it's still not, it makes you like, okay, do I feel comfortable productionizing something that basically is a coin flip? And that's really scary. It can also be prohibitively expensive, or in some cases, even actually impossible to collect more data. You could probably spend a lot of money and get the data that you need, but how much money is it worth? And then also maybe just like the circumstances in which this data was being generated no longer exist in the functioning universe. Like we can't, like, maybe we're talking about, the heart, like the biological data or like the health information of extinct animals. Like we can't possibly get that anymore. They don't exist on this planet. So how do we deal with that? And then another data challenge that a lot of people have is the bias that exists within data. Data sets can be skewed in representation and the representation can just be messed up. It can be overly skewed one direction. Hopefully that you have the opportunity to like see this, but sometimes people don't get the chance to see this. Sometimes you're unaware of this situationally. So your data can be biased, and like, what do you do? How do you make a model out of a biased data set? Well, actually, all three of these questions have the same answer, and the answer is synthetic data. I always love starting with a definition. Like I'm a definitions kind of person. This is a definition that's in a blog post that's written by our chief product officer, and I think it's a really good introductory definition. And it's synthetic data is artificially annotated information that is generated by computer algorithms or simulations commonly used as an alternative to real-world data. Now, that can be a mouthful, and there's a lot of big words in it. So basically, what it means is we're using computers to generate data that is representative of the data that you already have. That's what we're at. So the first question that you may ask, and the first question that I asked when I first heard about synthetic data is, well, isn't that just fake data? The answer is no. Synthetic data is very different from fake or mock data. Some of you may be immediately thinking of the Faker library. It's a very popular library for generating, fake data. Fake or mock data may not be representative. It's purely random. And if it is representative, you got that. You were lucky. Okay, let's be honest. If you can get representation out of dev random, then you got lucky out of that. And fake mock data can also just be too clean. Like it gives you perfect data. For anyone who's ever worked with data, we all know that data is not perfect. We know that data is messy. Like most of our web applications developers' time is spent sanitizing data that they get from users or anything, or even data scientists too. So whenever you get data that's too clean, especially if you're trying to like use this model in production to analyze data that's coming in, say from a web application or anything, you're training the model to be expecting perfect data. That's not the data that's going to come in. And it's an absolute it's unrealistic to think that way. So synthetic data is generated from your already existing data. So that way it will look and behave like the initial data set. So we take data we already have, we run it through a synthetic data generator, basically training it on a model. The model learns about the relationships, about the causalities, about what's happening in the data, and then generates data that is similar to it, that is representative of the data set. So it's already better than fake mock data. That's not to say there isn't a use case for fake or mock data. That's just saying that if you need there to be like correlation between the data, if the relationships that are in that data you need to be able to test against, then you might want to look into synthetic data. And synthetic data can be nearly as representative as the original data thing. And that's one of the things that Gretel really focuses on is our quality. And I'll get into that in a little bit later. And we have quality scores where we tell you this is the quality of the data. This is how representative it is of the initial data set. Cool. So let's talk about the benefits of synthetic data. So there are literally endless abounds to the benefits of synthetic data. Today, we're going to focus on 3. Because 3 is a happy number. We're going to talk about making private data accessible and safely shareable. We're going to talk about generating more samples with a limited data set. And we're going to talk about how we can reduce bias in machine learning data sets with synthetic data. So let's talk about making private data accessible and shareable. So one of the things that happens is data often contains PII, which stands for personally identifiable information. Sometimes I can't speak. we start over. This makes it very risky, or in some countries, mostly European, not America, unfortunately, it's very risky or even illegal to openly share this data or to work with this data. And let's be 100% honest. Developers and data scientists do not want your PII. They don't want that hot potato because now they are responsible for it. They want the relationships between the data. They don't care about the actual data. I would never want to work with PII. I don't want to sign that. And if you work for a public company, now you're a material insider, and now you it's a hot potato. Developers don't want it. We don't care about it. We want to know the relationships between it. So generating a synthetic data set allows you to have statistically similar data while removing the PII. This allows you to share your data, not only within the company, but externally as well. Imagine the world we could live in if we could take every data set that's ever been trained and we could put it in an open source repository, and every data scientist in the world all over the planet could access and use this data. We would get so much more done. But right now, the privacy gate behind it is what's really, really slowing us down. And this also is good for developers internally to the company too, because again, if we go back to the first example that I talked about in my presentation, we talk about needing access to the production database, but I can't get it. Well, now we can create a synthetic production database where the relationships and the natural trends that would have come out of the data in the first place now exist for where there's no PII, there's no risk of it. Even if it leaks, who cares? I mean, if the trends in your data are what you're trying to protect, then yeah, you have to worry about that. But that's usually not the case. Usually the things that people are more worried about are, oh no, my social security number is out on the internet. That's a lot more worrisome. So if we can do that, now every developer in the company can have access to this data, and now everyone can test and know that they are testing against a realistic set. So being able to make this data accessible and shareable is probably, in my opinion, one of the main primary and maybe the most important superpower of synthetic data. It has many superpowers. This is the one that Mason likes the most. The next thing we can do is we can augment, say, small data sets. This is really, really cool. So not having enough of the right data, not having enough of the right data is a serious bottleneck that we have. So if we don't have enough of this data, then we really can't do a lot. If you're in reality, if you don't have enough data in the developer case, then you're just not testing for edge cases, and you're waiting for the edge case to come in from production to break your code, and then you get paged in the middle of the night. Hopefully that's the worst thing that happens. There could be a lot worse things that could happen. When it comes to not having enough of the data in the data science space, your models just don't. Maybe you're not getting accuracy trained with your models because again, you just don't have enough to get the correlation. Data is often your most valuable asset, and collecting data is expensive and it's hard. If you have any data science friends, ask them. They will lament to you about this for hours. If there was one of those tweets of how to ruin a data scientist's day in 5 words, it's go collect data. That's how you can totally ruin their day. So synthetic data allows you to generate essentially an unlimited amount of data based on a relatively small data set. So what we can do is we can take this data set, we train the model on this small data set, and then we can generate as much of it as we want because we know the correlation. Now, there is a question that always gets asked, and the answer is yeah. If that data is inherently bad, if that small data set is bad, does that mean it will produce more bad data? Yes. It is kind of it's amazing stuff in, amazing stuff out, but it can also be garbage in, garbage out. So synthetic data is not smart enough to tell you, hey, this is bad data. You have to be able to figure that out for yourself. But in reality, what it is if you have maybe 1,000 records and your model just can't, that is enough for your model. Now you can generate 10 million records and now your model's happy. And then you can go from there and you have to go, okay, well, is this representative? And then, it allows you to iterate on the process because now you're not having to worry about quantity of data. Now all you have to worry about is quality of data. And that's, one less thing for someone to worry about. That's a good thing to not have to worry about. This problem is especially prevalent in the public sector. Poor data practices across government entities, such as storing data in PDFs, which are completely unreadable from a programmatic standpoint, causes for an absolute abundance of inaccessible data. So we we've kind of like a lot of the stuff we want to do, we can't do because we haven't stored data in a way and we don't have enough of it. So now that we can augment it, now we can like start moving this thing forward again. Now, the last one, and this is like one of the coolest ones to talk about, is reducing bias in data sets. So bias data is a big problem. In reality, it leads to inaccurate models, unfair results, or even cause harm. So like in the worst case, in the best case scenario, your model's just inaccurate and you don't use it. In the worst case scenario, it's actually causing mental or physical harm. Like bias in data is a very, 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 very big problem. So if you can identify the data set bias in your data set, though, you can then use synthetic data to balance this data set. So there's a really cool case study, and these slides are on my website, mason.dev. You can find them. I will also share them with everyone. And there's links to some really cool blogs, but there is a blog and a case study that we have done that is reducing AI bias with synthetic data in heart disease prediction models. This is a very popular data set, I believe, on Kaggle, or is it Kaggle or Kaggle? I never know how to pronounce it. And in that data set, 68% of the data is male and 32% of the data is female. So we have a 2-to-1 ratio of male to female heart patient data. So we already have a biased data set. This model is not going to be as accurate as predicting heart disease in females because the data is not balanced. So what we can do is we can use synthetic data and precede the model with female data and say, hey, I want more data on female patients. Create me data, look at the data that is female, and create more of it for me. And that's exactly what happened, is we were able to take that and then balance this out to where it's a 50-50% split in it. Someone is asking, can we publish the blog link? I will, you know what, I can grab it real quick and put it in the private chat. I know exactly where it's at because I talk about this all the time. I'm also going to take this as an opportunity. Well, actually, I'm going to finish this one thought and then we're going to take this as an opportunity to ask some questions. So the thought that I'm going to finish is we've done this and it increased the model accuracy from 88.5% to 96.7% of predicting heart disease data. So that's 6.17. My math might be wrong. I don't look at that. My math seems wrong on that. More females with heart disease that can accurately be diagnosed. So let's go ahead and grab that heart disease blog real quick. Oh, no, I can't find it. There it is. So I will put this in the private chat and they will drop this in the chat for you. So let's go back and look at some of the questions. I saw a couple of them come in, but I wanted to get through where I was at.
Yep. So we've got the first one from, sorry, I'm going to murder your name, Goriel. I'm so sorry. So basically they were asking whether there was a way to verify the representativeness of synthetic data.
Yes. So one of the things that Gretel does is we have what we call our synthetic data quality score. So we have, and there's multiple blogs that we have. We've created a method using 3 primary different methods, which I cannot remember, like 3 different mathematical ways. I wish I could remember them off the top of my head, but I can't. On basically telling you what is the quality of your data score. And I can actually let me see if I can pull that up real quick. SQS. Sometimes I don't know what I'm yes. So let's pull this over here. So we have the Gretel data, the quality synthetic data set with Gretel evaluate. So we already have the Gretel synthetic report. So it tells you the field correlation stability, the deep structure stability, and the field distribution stability of your data sets compared to the original. And then this blog that we have right here is announcing Gretel evaluate, which is a new open source tool that we have. So in the past, you were able to get the synthetic data quality score of synthetic data sets that were trained on Gretel. Gretel Evaluate now allows you to get the synthetic quality score of any synthetic data set, whether you trained it on Gretel or you trained it elsewhere. So yes, we have an entire fancy quality report that is generated that we use to verify that, hey, your data is of good quality. So it's a great question. And I wanted to make sure I brought that. I chatted about that. And I can link this blog into the private chat as well for people to go ahead and post. And okay, so we have one other question.
Yes, so that one was from Ari. So could you explain more about how time series synthetic data is generated? Very interesting question.
Yes, it is. Unfortunately, I don't know a lot of the how, but I know that we can do it. So we have a model called Doppelganger. And let me see if there's a blog. There's always, like, if there's one thing I love about working at Gretel, we love to write. And so many people write amazing blogs on how to do anything and everything. Like, our content quality here is through the roof. So I'm going to put another blog here in the private chat that they'll post. But it's basically this blog right here, creating a synthetic time series data with Doppelganger and PyTorch. So Doppelganger is one of our newer models. It's currently in our open source library, and it's coming to the actual console platform soon. But this blog will definitely walk you through how exactly, with code examples and everything, on how to generate synthetic time series data. It does definitely seem that so many people always ask about time series. It seems to be like one of the main questions I always get is time series data, which is awesome and fascinating. Yeah.
We did actually just have one more come in from Merlan.
Okay.
Actually, no, we've got a couple actually. So Erwin has said, I understand bias is presumably a bad, undesired thing, but wouldn't synthetically altering the bias introduce a bias in and of itself? E.g., there's a reason for there to be this sort of 2/3, 1/3 ratio as in the heart disease data.
Maybe. So basically, typically what happens, I mean, I can't speak to all things. I feel like that's almost a philosophical question. But let's talk about the heart disease thing in particular. So, if I understand correctly, men are more susceptible to heart disease than women, which leads to there being that. But also, men report their symptoms where it has been. We have studies that show that women typically don't report symptoms of heart disease because they look vastly different. Like, we've learned in the last couple of years, as someone who has heart disease in their family, I'm learning a lot about this. Men and women present heart disease symptoms vastly differently. So there could be the issue of women just not going to the hospital. So they're shrugging it off because, I think there is also data that women in certain aspects, especially this one, can have a higher pain tolerance. Or again, like, I think with women, like upset stomach, like chronically upset stomach is one of the indicators in heart disease, but that's not a primary indicator in men. So, but there's so many reasons to have an upset stomach. So you're like, oh, maybe I just had some bad food. Maybe the kids caught a bug at daycare. So they're not presenting it. So in this case, I would say that the bias is we just don't have enough of the data. We know that women get heart disease, and we know that we need that. So we need to be able to augment the data set for there. As for like maybe the bias in the data set is representative of something, that is a philosophical question that I feel like whenever you're training your models, that's something that you have to discuss internally to yourself. But if as we were able to see, the model got more accurate. So it didn't get like, if that were the case, if we were introducing a secondary bias, we would expect, I assume, the model to either not move or the model to become less accurate because we've introduced another bias that would affect it. But since we didn't see that, we actually saw an increase, then my assumption is that the people that were not being accurately predicted by the model were women. And by debiasing it, we were able to predict better for women. Therefore, we did not introduce a new bias in that data set. We, in turn, actually helped remove it. That's such a deep question. I would love to get my founders' thoughts on that. Like, I would love to just take this to my engineering group and be like, look at this question. Let's talk about this.
And this is the thing too, like bias is such a data set by data set thing. And you're totally right. Like one of the reasons might be not just presentation, but doctors have also been found to underdiagnose women with heart disease because of this asymptomatic presentation. I also used to study heart disease actually. So
fantastic.
It's a great topic.
Okay. Well, did I get it right? Like, was I kind of right in my assessment there?
Yeah. So it's more that like there's a quality in classification models where if you have more even groups, it's easier for the model to predict better, because essentially what you're saying is if you have 2/3 of your target as one group, the model can just guess and not really learn. Whereas if you even it out, it actually makes it better for the model because it has to then truly learn patterns. So then when you apply it to a new data set, it's actually made a proper model rather than, just memorizing patterns or guessing in the training data. So yeah, like it could also be there's bias in your test data, but you're totally right that it's a very deep thing. Bias is such a domain specific thing, and you really need to assess for yourself, data set by data set, whether you can actually generalize from that.
Oh, that's fantastic. I'm so glad. I'm glad you're here to help me with that. Like that was literally Mason working through the problem in his head in real time and talking about it. And I'm glad that I got close to it being right.
Yes. Yeah.
That's fantastic.
It's a very specific kind of statistical thing. Cool. So let's jump into the next question. So we have a question from Merlan, and they've asked, how risky or safe is it to use synthetic data to create synthetic borrowers to work on the development of scoring models? So I'm assuming you mean like in credit scoring models would be my guess.
Maybe. So I know that if that is the case, because I don't know what a synthetic borrower is. If that is the case, I don't know how risky it is, but I do know that one of the primary use cases is for synthetic data right now that we're seeing is financial data, and people are using this for that. Now, are we going to come back in 10 years and learn that this was a terrible way of doing something? It's possible. We do that all the time in science. But as of right now, financial institutions are very much jumping on the synthetic data thing for not only being, I don't know if they're using it for credit per se, but I know they're using it to detect fraud, to be able to generate fraud-like events and then, be able to test code against more fraud-like events. So that would be my answer to that one.
That's also interesting too, because, so I also used to work in programmatic advertising, and we had a similar problem that I think that banks would have, in that you censor your data. So basically what you do is you have a whole bunch of people that you don't want to send ad auctions to. And so that means that when you go to train your data, you have the data is not complete. And I imagine the same thing would be with like borrowing data. You have a whole bunch of people who you've denied a loan to on the basis of an established credit risk. So you can't actually train your models properly. So what you might want to do is actually collect a very small but representative sample that's not censored, and then create synthetic data from that. And potentially that's a way to actually get more representative data that's safer to work with.
Oh, that's really cool to think about. I'm still so new in this space. I love talking and hearing people talk about it. It's so cool.
Yeah, I think this actually, it's a really fun one for us to do together, because we can sort of feed off what each of us knows. Cool. And then one last one, and then we can get going. So we have a question. What about not tabular data, but pictures, text, voice recording? So can we create synthetic data for this sort of import?
Yes, there is synthetic data for all of these. Gretel currently does not support images or voice recordings. Those are obviously going to be coming in the future. Text, yes, we have a GPT model. I'm going to be demoing GPT-3. So we'll get to pictures. A fun thing about pictures and like what is one of the most common use case for synthetic image data is actually in self-driving cars. They're using that a lot to generate images to train the models so the self-driving cars, don't hit a pedestrian. So that's a big use case for synthetic image data. It's not something that we support at this exact moment in time, but it's something that we are definitely like working towards. The cool thing that you're going to see about Gretel is like we just released it beta in February. So like we're adding more and more models, we're adding more and more functionality. So right now you're kind of getting in at the real early time, but the longer you wait, the more cool models they're going to be that we're going to have trained ready to go with this.
Awesome. So I think we can let you go.
Yes,
you can keep going with the presentation now.
Yes. I love answering questions and stuff. So thank you for asking those. I felt like that was a good space to go. And now we can move into the next one, which is the next question that a lot of people like to ask: is synthetic data accurate? And the short answer to this is yes. More often than not, yes, it's very accurate. Unlike fake data, as we mentioned earlier, synthetic data is nearly as accurate as the real data itself. There are blog instances and cases that we have shown where we've actually improved accuracy in synthetic data than over the initial data set, which that sounds completely far-fetched and out of my mind, but we proved it and it worked. So again, magic. We're in the magic phase right now for Mason. Augmenting a training set with synthetic data that we typically have done or that we have seen had a mean machine learning accuracy of less than 1% from the real-world equivalents. So the quality there is accurate, and we are seeing accurate synthetic data. As everything, I'm telling you right now, like, synthetic data is the answer to everything, but there has to be some challenges, right? Like if I stopped there, you would think that I'm selling you like a car with no brakes or something. There are obviously going to be challenges with synthetic data. It's a very, very, very new topic. Like 3 years ago, I don't even think this topic was like on anybody's radar, maybe even less than 5 years ago. This is so new. So what are the challenges we're currently seeing with it? Highly dimensional data sets with hundreds of thousands of columns can be compute intensive. For anyone who's trained models, you know, the more data you pump into it, the more GPUs you need. This is definitely one of the problems that there is. So you have to, it's not saying that there's something wrong with synthetic data. You just have to know that if you want to do really big data, you're going to need really big machines to do it. Synthesizing relational data sets currently can require some manual configuration to be able to keep those correlations between the keys. So there is a little bit of manual stuff in there, which I think at this point in time, if it yields the results you want, a little bit of manual work's not that big of a problem. I think it still leaps and bounds better than where we were. Some privacy-preserving technologies, such as differential privacy, require very large amounts of data to provide strong guarantees without degrading the accuracy, and thus may not be appropriate for all data sets. So one of the things we haven't even really touched with the synthetic data, at least on the Gretel side, is like not only does Gretel have the synthetic data quality report, it has the privacy report as well, which tells you like that's the two things that Gretel really is focusing on: high quality, accurate synthetic data, privacy protected synthetic data that you will be able, that that if you wanted to share with someone, you feel confident that that data is not going to be able to be reverse engineered or reverse attacked to get the data back out of it. And those are some really fun, those are some interesting attacks. I was in DevOps. I did cybersecurity from a DevOps side of things. So I understand cybersecurity. And then I hear about these data security attacks, which I had never heard of in my life. And I was like, oh, that's like, my first thought was, it's so cool. Like, I can't believe you can do that. And my other thought was like, oh, that's a bad thing, Mason. No bad. Like, but it's also still cool. It's like, I would love to like play around with that sometime. But anyway. And synthetic data generation requires time and effort. Like this, it is like all things, we're training a model. It's still computationally intensive. It's not as like time intensive as I would say, like 5 minutes. Like sometimes with our models, like with some of the stuff that I do, the demos I'm going to demo today, like 5 minutes. But like if you're trying to like stream real world synthetic data, you're going to have to architect some sort of buffer for now. But where do we see synthetic data in action right now? I'm going to list like a few, and there's a lot. Automotive and robotics, leveraging synthetic data environments for training robots, self-driving cars, and even testing safety and crash prevention technologies. Financial services, creating synthetic time series data to enable data sharing that doesn't compromise the customer's privacy. Cybersecurity and InfoSec, using synthetic data to train machine learning models to better detect rare events, including fraud and cyber attacks. Healthcare and life sciences, creating synthetic genomic data, as I had mentioned earlier. Also, all of these links, which you'll find on my website, I'll send this to the JetBrains people as well. These are all blogs on Gretel's thing of all the case studies and all the things that are doing it. So creating synthetic genomic data to fuel medical breakthroughs and encourage better medical care. Manufacturing. This is the one, when I get asked about time series data, I'm always asked about manufacturing engineering. Using synthetic data to simulate complex supply chain operations and predict when failures may occur. Such a cool thing. And more. There's so much more. These are just like this entire presentation is based off of the blog on our website, What is Synthetic Data? And this is like the first third of the list. So if you want more, I'll drop a link to that blog. You can go find it. So what does the future hold for synthetic data? So this chart right here, that's a little bit small, but the same is by Gartner. But basically they're saying by 2030, Gartner predicts that synthetic data will overshadow real data in models. So they're expecting that as the synthetic data community grows, more and more people are going to be using it because it's easier to access. This is already happening today. This allows for easier compliance under data protection laws, such as that should say GDPR, CCPA. It's reducing the attack vector on data. If you're someone who does security, you know the more people that can touch the sensitive stuff, the more likely it is to get broken. My first job when I out of college, which is funny because our founders and a lot of people in my company worked there alongside me in different departments, and I didn't know it was called ForcePoint. It was a cybersecurity company, but more often than not, data breaches and stuff like this are not done because somebody sat at a computer and hacked your web server and was able to they're doing it because someone left their password on a sticky note. Or it's social engineering is the primary way of getting in. So if you can reduce the amount of people in your company that have access to this sensitive data, then the attack vector shrinks unbelievably. So how do you get started using synthetic data? There are a lot of resources available. There's this opensourceagenda.com tag synthetic data you can look at. We currently are working on curating an awesome synthetic data list. You know, if you're familiar with GitHub, the awesome lists, we are curating that. If you have any you'd like to add, please submit a pull request. I will accept it. Gretel makes it easy. I'm here today to tell you about Gretel. All of our models are currently open source, so you can go and you can train these models yourself. They may require a lot of computational power to do so. They 100% require GPUs to do so. But if you wanted to train the base model yourself, then you could train it. There are no code options. It runs in cloud or on-prem. We understand that sometimes people's data cannot leave a physical location. So being able to run it on-prem is a big thing. I will say there's a lot of really cool benefits in the cloud, the synthetic quality score, just the ease of use. So like I recommend running it in the cloud. If you want to run it on-prem, you're going to pretty much have to be a Kubernetes expert to be able to do it. So like for large scale institutions, I can see, but if you want to play with this today, like if you get off this webinar, you want to go play with it, go run it in the cloud. We have a free tier. Oh, look, my stuff's out of the way. So all of this is based on our open source open source model. So if you want to go see the exact model that we use to train, you can 100% go see it in Gretel Synthetics. If you don't have a GPU and you just want to try it out and you want to just try the free tier, go right ahead. I honestly think it's the best way to do it. We give you it's a very generous free tier, and it lets you just play and like get your first synthetic data stuff open. It's a great thing to start. There's many ways to run. There's a dashboard no-code option. There are CLI options. We're going to talk today specifically about doing this in Jupyter Notebooks using a Python SDK. There's a REST API. There's tons of stuff. So let's go ahead and get to our demo.
Can we just have a quick pause just for one question?
Yeah. Yes.
Yeah. So James sent in a question saying, if you're creating synthetic data from data sets with PII, how do you ensure that the synthetic data isn't too close to the real data and therefore might expose PII?
Yes. So we use tools like differential privacy. Gretel also has a couple of other a tool called transform, which will basically identify PII. And then, so there's 3 Gretel products. Synthetic data is the one that we the flagship. And then the other 2 are basically helpers. So there's classify, which classify uses natural language processing to detect potential PII in things. So you could use this classify to detect the PII. Then what you would do to ensure it is you use our transform, which will then take the data set and will transform the data. It does not do synthetic data, but it transforms it. So then now instead of it saying Mason Egger, it now says, I don't know, someone. I can't think of a base name off the top of my head. John Stewart. I don't know. So it will synthesize that. And then what you do is you take that transform data set and then you feed that data set into the synthetic data model. So that way, at the time that the data was generated, there was never any actual real PII in it in the first place. And cool. Then we have things like differential privacy. Like there are knobs you can turn. The more advanced you get, the more secure you want your data to be. I think, as we mentioned in one of the challenges, is that if you want to use differential privacy, that requires a lot more data. So your data set has to be equivalently much larger to do that.
Yeah. And would you just quickly explain what differential privacy is?
Can you do that?
I can actually.
Go right. I have like a skim top level understanding of differential privacy. I don't feel quite comfortable yet explaining it, and I would love to hear your explanation of it, because then maybe I can use that whenever I explain in the future.
I'm just going to give like a very dumb explanation as well, because I wouldn't say I have the deepest level understanding. It's essentially just adding a little bit of noise to your data set that's proportional to sort of the amount of natural variance. So say you have, I don't know, the amount of app downloads, it's going to have a certain amount of spread. You'll just add a little bit of noise to every single observation in order to make it close to the original, but not able to be reconstructed and, tied back to the original. So it still mimics real data, but it's not identifiable anymore.
Oh, that's fantastic. Yeah, that's when you explain it like that, 100%, that makes sense. That we do this in security all the time, but I've just never heard of it referred to as differential privacy.
That's all it is in data science. So yeah,
it's amazing how similar some of these things are. Awesome. So let's go ahead and do let's generate some synthetic data. So we have our notebook here. This looks correct. We're going to import it. So the first thing we're going to do, so if you were doing this, you have to install the Gretel-client library. which we're not going to do now because I want to save some time, but it's pip install Gretel-client. And then we're going to need pandas, and that's about all we're going to need for this. So let's go ahead and run this here. It seems that my credentials are already cached, but let's go ahead and just go through this as if my credentials weren't cached, and I'd have to show you how to do this. So actually, let's just start at the beginning. It's a great place to start. You go to Gretel.ai, and you click the sign in button. And then I'm a big fan of these single sign-ons now. Like, it makes life a lot easier. So we start here, and this is our dashboard. Like right now, my dashboard's empty. I cleared it out. But we have an API access key. So you just come down here, you copy the access key. You could, just directly upload a data file here, edit the configuration, and do it as a no-code option. 100% an option, but I'm going to show you how to do it with the SDK. So we're going to copy this. And then whenever we hit like this run, it would have come up with a prompt box, and it would say, hey, enter your key. We enter it in, it does a login. You're now there. And then the next thing we're going to do is I'm trying to figure out how I want to display this. Yeah, I think that works. Yeah, we'll just, since the code is over here, we won't really, but I like the syntax highlighting. I'm a syntax highlighting person. So anyway, so we're basically what we'll do is we'll, from the projects, do a create or get unique project. So it either creates a new project, or if it already exists, get it. We're going to call it synthetic demo. We're going to get a model config, and we're going to just read the model config. There's a default config for all synthetics. This also would appear in the dashboard if you were to do it. It's all over our documentation. But for our case here, we're just going to use the default because it works pretty well. Like, we've tried very hard to make our defaults as absolutely useful as possible. So, okay, so that it didn't have any output, so I didn't think that it had run. I still am getting used to that in Jupyter Notebooks. It's like, did it run? I can't tell. Okay, it did. So the next thing we're going to do is we're going to import pandas. We're going to get a data set path. So we have a U.S. adult income data set that we have that basically has people's education levels, income levels, a whole bunch of just data set in there, which we'll see here when we dump the data frame. And I almost kind of want to do a data frame.head here just because I don't want to dump the whole data frame. We're basically going to just read the CSV from it, from the path, and then we're going to basically save it as our own, and then tell it we're not going to index it, and then we're going to show it. So let's go ahead and run this. And here's our data set. So age, what work class they are. I don't know what that number is. Their education, and there's like a whole bunch of data. But what is it that they have? Income brackets, all this. So this is just a random data set we're going to use. It's not fun. It's not very amazing, but it works. Sometimes I really want our data sets to be fun, but sometimes they have to be practical too. So basically what we'll do now is we just create a model object with the config and the data source. We submit it to the cloud, and then we pull it, and we just watch and see what happens. So this is where we'll have some time to actually discuss, because it's going to go create the config in the cloud. One of the things you'll learn from our config, and I'll show you here. So it creates this UID. This is the default config that it sent, so you can see it. Schema version. Again, all this you don't really need, but you need it. I'm sorry, you need all this stuff. But like, very unlikely that you're going to need to tweak some of it. What you would maybe want to tweak is some of the parameters down here, which are basically hyperparameter tuning. So if you want to change the number of epochs or the batch size, or there's a learning rate one here, you can tweak, at least maybe learning rates for GPT. But there's all of these different hyperparameters that you can tune that are documented, that please don't ask me what they mean. There's a lot of them. And basically our validators, all that stuff. So basically what it's going to do now is the Gretel Cloud Worker is being allocated for the model to begin the model creation. And it's just going to go ahead and do that. We're going to wait here a little bit as it's trying to allocate. And then, so if we have any other questions in the chat, we can do that. If Jody and I just want to just talk amongst ourselves while we're waiting. We're in the, there's a really great XKCD where there's two people, actually, I know I can show XKCDs on screen because Randall Monroe's cool like that. He's like, as long as you're, not, as long as you're not making money off it, it's fine. So this is like the legendary XKCD. It's like get back to work. My code's compiling. Oh, carry on. I feel like all you have to do is change compiling with my models training.
Yes.
So that's where we're at now, is we're waiting on the model to train. And as you can see, the model, while we were talking about XKCD, the model has started training. So it's doing load training the data, loading it all in, the record count, the batch size, tokenizing, shuffling, initializing. So, and then now it's going to start reporting on the epochs or the epochs. Okay, Jody, how do you say that word?
I say it as epoch.
Okay, good. I've had people say epic. I have people say epoch. I don't know which one.
Here's the thing. I'm a weird Australian with my weird Australian accent. So I never want to tell people that this is the right way to say things.
I like epoch too. Epic sounds, I don't like epic. I like epoch.
Yeah, epic sounds a bit like epic. It's a bit, yeah. So we have actually had a model. We've had a question come in. Which model are you using?
So this one is using, this is our own model that we have generated. This is called it's LSTM, long short-term memory model. And I don't know where it is in the GitHub repository. I think it's actually just part of the part of this general code. But this was the first and the primary model for Gretel Synthetics. So if you go to the Gretel Synthetics GitHub, which I'll zoom in a little bit so you can see a little bit better, this model and all of our models are contained here. So if we go in here, for example, you'll see time series DGAN, which is our time series doppelganger 1. But this model is our base model, first model. It's just Gretel's open source model for doing synthetic data.
Actually, question I have. So you're obviously open source in terms of the packaging of the models, but essentially, is your model code open source, or is that proprietary?
The model code is open source. So I think the whole model code is open source. What we do, the value that Gretel brings is in the ecosystem. So the synthetic data quality score, which we now have in Gretel Evaluate, is extremely valuable. The privacy score that we have is extremely valuable. The way that we're getting to the point where we're going to be able to stitch models together, like being able to multi-model train synthetic data, that is where a lot of our really cool magic is. So like the GPT model that we have, that is basically just a re-implementation of OpenAI's GPT model, just trained on a much smaller data set. So yes, all of our models are going to be open source, and you can use them if you want to. Totally up to you.
Wow, it's really impressive actually, because it's a lot of work to develop, especially like a LSTM from scratch. So yeah,
yes,
my hat off to you.
Awesome.
We did have another question come in from Juan. Can I use a TPU instead of a GPU?
What is Google Corral?
I haven't heard of it either. Sorry, Juan. Is it like Colab?
It might be. I actually don't know if you can use a TPU.
Yeah.
I've only so this is really funny because I literally just learned, I've seen that's the first time this week, a couple days ago, I saw the acronym TPU and I thought it was a typo, and then I looked it up. So the fact that it's come up twice in a week means obviously it's something new and it's something cool that I need to go look at. But
yeah, it's basically, I don't have a deep understanding either. If anyone in the chat knows, please feel free to jump in. But my understanding is there you go. It's Google's GPU. Yeah, it stands for Tensor Processing Unit, and that's the extent of my understanding. Yeah, thanks, Erwin.
How many epochs did I give this thing? I think the default is hundreds. Okay, so we're gonna be here for a bit. It's still going. It's still going. Okay, normally I think on some of them I thought I stop it from doing this sometime. Whenever I do this other one, which actually we can start on that. Let's start on Gretel. Let's start on the Gretel Bartender, because we can run them both at the same time, and then we'll come back to that one. That way, just to save us a little bit of time, because I know we are running towards the end, and I want to get to GPT. So Gretel Bartender is another GPT based one. And we had another question: how is it using LSTM in the structured data? I have no idea. That's an answer for the research question for our research scientists. So yeah, I can definitely ask them that question. If I get an answer, I can send it back to JetBrains and they can get it out for you. So yeah, so if you look at the code for basically setting up brain can't talk GPT, it's very similar. This is one of the values of it, is the library is it's the same library. It's just changing the config. So we have this import JSON here. We're going to go ahead and create a project with the endpoint. Okay, this is where it's asking for my Gretel key, which I think I still have in my dashboard. So yes, it has come through and said, hey, we're there. I don't know why I have project here and it's printing out, but it creates a project. That's a hooray for typos. And then this is an example of the config. So this is the GPT, we call it GPTX model internally. It's the Eleuther AI implementation with it's basically GPT Neo. So some people may know that phrase. Trained on 125 million records. So this is, if you were to write the config yourself, you would write the config as such. Just basically put it in JSON. It's going to print out the JSON here, so you have a pretty JSON to work with. GPT the GPT model only takes one column as data. So if you have multiple columns that you want to do, you need to concatenate the data together. This is where I was talking with Jody earlier. I had another model that had some weird encoding in the file, and it was just not happy with Mason. And it did not work. So we can concatenate this data. And as we can see here, this is the original data. Like, this is the brain teaser. It's 30 milliliters of this type of alcohol, 30 milliliters. Here's the instructions to create it. Okay. So just kind of look at this here for a second and just see like the format that it comes in. Okay. And now what we'll do is we'll train the model. So we'll go ahead and run this model, and it will start training for us in the exact same way that it has, that the other one has. This should hopefully be working. I had a little bit of weird issues with this one last night. So if it doesn't work, I apologize. But I think my last execution is still there, so we'll be able to look at it. But that one was, I don't know, there was some kooky going on. Okay, and while we did that, the model creation has been completed for the LSTM. So now what we're able to do is we can just view and read our synthetic data. So we're able to so what it did is it created a base set. It put it up basically in a brain in a secure S3 bucket, and you can just download it and then view the synthetic data. So let's view the synthetic data. Let's go to preview only. So as you can see, the data is relatively the same. There obviously was some interesting stuff happening with the occupation, but we have private. It's got its own whatever score that is. And this is all fake, but this is all synthetic data. It looks very similar to the data set that we originally had. And now we can work with this data. Say if there was any actual PII or material information in this data, now you have a data set that you can easily share and not have to worry about leaking out the data. Cool. Let's go back to the bartender.
That is fascinating. Yeah, I'm actually also curious about how the LSTM works. So as soon as you send that link through, I'll also be reading it.
Yes, I will totally try to get that for you. So there might be something in our blog about it. Is this model being cranky with me today? Sometimes it gets like weirdly stuck. So let's try to where's my Gretel thing? Actually, yeah, let's go back to the console and just look at a couple things. So let's look at the synthetic demo. So this was the one that the LSTM that we trained. Well, another cool thing here is now if I want to, once I've trained the model, I can come here and I can just generate more records from the console. So I don't have to go and I don't have to run this notebook again. If I want to create 100 million records, I can come here and do that. Our quality score is 91 out of 100. So, I mean, we're at 90% accuracy on that. The data sources, it can show us the data sources. We have team membership and stuff. So you can add members to this. You can, like, if you want to collaborate with people, there's a whole bunch of settings you have. So cool, so nifty.
Yeah, it's nice.
Activity tells you all the activity you have. You can view the configuration of the model that you trained, so you can select if you ever want to come back. And then this is our synthetic quality report that we have that we talk about. So field correlation stability on this data set was an 89. The deep structure stability, a 91, and the field distribution stability, a 94. So that's how we got those. Again, the blog that we linked earlier explains those in much deeper thing. And then we have the privacy protection level of very good. I'm curious as to where the rest of the stuff is on that, but I cannot seem to. Maybe let's just try downloading and see what we get. So
I can actually sort of see why it wouldn't be like totally up the top, because you do have like PII in this sort of data.
Yeah. So, or actually, I don't know if there is PII in this data or in this particular data set. Okay, so this is where it talks about our privacy. So you have to download the report to view the privacy report, but it has outlier filter. It says medium, the similarity filter, overfitting prevention. So these, I assume, are the attacks that you can perform on them. And then we did not enable differential privacy, so we didn't have it on. You actually have to enable differential privacy because, again, it is a very it's much more intensive. The model takes longer to train. There's a lot more involved in differential privacy. And then it gives you a training field overview. And this is this is the correlation. So we have the training and synthetic data correlation, and the correlation difference between them. So this is the field correlation stability. So we basically check field correlation and see. And then when you come over here to this heat map, you can see where. So like this looks like this point right here, and like these points were like the hottest. This is where it varied the most. The principal component analysis, where we flatten it and then we kind of just look at, does the picture kind of make the sense? And then field distribution, like how different are the fields betwixt each other. So yeah, there's a whole lot in this. We did a lot to ensure you that this is quality synthetic data. So let's go back here. Okay, this GPT one seems to be there's a transient issue where every now and then, whenever Mason runs something, it gets hung, and it's hung on this one. But we'll go forward and just say, hey, let's look at the actual. Okay, so this is one from the last one. This is actually a little bit more of an advanced sample or example where we are. Is it? No, it's not. This is the first one. Sorry. There's a couple of them where you can precede it, and this is not the preceding example. This is the base example. So I ran this last night. You can imagine that it worked. Some of them, as you can see, are a little bit kooky. GPT is still kooky. Like, spoiler alert, it's not perfect. It's still relatively kind of kooky. But this one right here, like the second one, it's called the sugar orange. 2 ounces of lemonade, ½ ounce of gin, juice of 1/4 of lime. Stir the lemonade and gin. I mean, like, look, this is. You would think this was written by hand. Now, I cannot verify the tastiness of these drinks. So do not blame me if you generate a synthetic cocktail and it doesn't taste good. There is no tastiness correlation factor that we have here for this. But I mean, if you look at just this one and you compare it to the initial data set, it's almost identical. Like I would not, if you were to put them side by side, I would not be able to tell you the difference between them, which is what you're going for. Now, can you do other stuff with GPT besides drinks? Of course, chatbot data is great for this. There are a lot. Chatbot data is a big one. Call center data. There's a lot of absolute value to text generation. So yes.
Yeah, I used to work. I used to work in a job board. I've had a lot of jobs.
Me too.
Yeah. So, like, we used to work with text data all the time, and it would have actually been super cool to be able to generate more of like rarer job ads, or things like that.
That is 100%. But that, and if you think about it, it's the same. That's how we debiased the heart patient data set. Is we basically selected a type of record that we wanted more of. So whenever I get asked questions about time series data, and it's always Internet of Things and it's always supply chain, it's like, these sensors run on this manufacturing floor for years at a time. They throw an error once in their life and then they die. So like, it's very difficult to get any data around that, because once every 3 to 5 years a sensor dies. How can we generate more of that? Well, you identify the thing that you want. You can then precede the model with this error case or this use case or any case that you want, and then you could augment more of them, which I think is Erwin's question in the chat about what about outliers.
Mm-hmm.
Yes. So yeah, that's. We'll go back to my slides now because I have a little bit more to share. Before we go, additional resources for anyone that wants more resources. Docs.gretel.ai. I mean, just go to Gretel AI, but the docs are there. I love our docs. I think they're very well written. The Gretel blueprints. This is a great GitHub repository. So if you want, and I'm actually going to show this on screen real quick if I get 1 second to grab this on GitHub. So Gretel blueprints. This is the data set we use to balance the heart disease. This is how you balance data with conditional data generation, data de-identification, locally transfying. So these are time series generation proof of concept. So if you don't want to have to like bumble through the docs and figure out how to do it, we've already got the code here for you. We've given you a starting place for almost every problem that we can think of currently. So you want to create synthetic data from a time series? Here's a notebook. This is a notebook just for you. Open it up in Google Colab and get at it. So Gretel Blueprints is like our starting point, our baseline for all of them. It's one of my favorite repositories. There's also, and I'll talk about the fun. Like, there's another one called Fun with Synthetic Data. that I maintain. And if you want Gretel Bartender or you want the lyric generator, these are fun things you can do with synthetic data. They may not necessarily have any actual real world production value, but if you just want to play with something, this is a great place to start with it. Okay, so back to this, which I already had linked there. And now for the part that everybody wants, free swag. So if you go to Gretel, grtl.ai, so Gretel AI has vowels, grtl, it's our bit.ly link, it does not. So grtl.ai/PyCharm 2022, or you just scan this this QR code. I'll leave it up here until the end of the presentation for people to scan. And you give me like your shipping information. I will send you this sticker that's in the screen. And then if you want to learn more about synthetic data, just check the little yes box and we will reach out to you and get you more information about Gretel and about synthetic data. So this is all I have for this time. Thank you for having me.
Oh my God, it was such a good talk. I really enjoyed the chat that we were able to have. And thank you everyone so much for the questions. It was great to see the engagement. I think we had some really good conversation. So we are going to get up our closing slide now, just so that we can show our kind of, where you can contact Mason and where you can learn more about PyCharm if you don't know what it is.
Can we go back to my slides for 1 second? I forgot a slide.
Yeah, of course.
Okay, so you can follow me on Twitter. If you want to know more about Gretel, follow Gretel AI on Twitter. If you have questions, like immediately after this, join our Slack channel. Remember, this is grtl.ai. That's the short one, but it's easy to find on our main website. If you want to join our Slack channel, join the Slack channel. If you want to get started with Gretel, go create a free account. Have fun to your heart's content. These slides are on my website. I will also send them to Jody and team whenever I am done. Okay, that's the last slide I have.
Perfect. Cool. So we'll jump back over to the PyCharm details. Please get in contact with us if you have any questions. Please get in contact with Mason if you have any questions. If you think of something after the presentation that you weren't able to ask or you're a bit too shy, we would love to answer those. So thanks again. It was a really great presentation. I really enjoyed it. I hope everyone watching enjoyed it. And just let's sort of wrap it up. So we're always looking for some ways to make our webinars better. So please do reach out to us on Twitter or the after webinar survey if you have any feedback. We promise we do read these surveys, so the feedback is really useful. And that's it for us today. So thanks so much for tuning in and enjoy the rest of your day, your evening, and enjoy your weekend. Bye.
Bye.